Good afternoon, everyone. Thanks again to Dawn and ETC for inviting me here. It's really an honor for me and an opportunity for me to try and give a little back to Dawn because I owe her so much. And so my time here is really for her. I was an engineer before I became a surgeon, so that's my relationship to testing and all that stuff. I thought it was important to add a surgeon's perspective as far as developing a product, because in this field, getting the surgeon's input on product development is very important. And so I'm going to talk about that and give an example of a real product that I developed before we started Spine Frontier and kind of take you through that journey. So if you're about to develop a product, whether you're working for a company internally or you have an idea on your own, this lecture will help you. And the first thing I think is important for you to consider is there a demand for your product? Because there's no shortage of patent application in the patent office. I can promise you that. And there's no shortage of ideas. And literally every week I get new ideas pitched at me for Spine Frontier. And they're great ideas, but we have to ask ourselves, what's the demand for that? And the next thing we do is, look at what the current system is. So if you come up with an idea that's so revolutionary and there's no real demand right now, it's a problem. But if you're coming up with an idea that has precedence, you have to understand what's the opportunity. And one way to look at the opportunity is to look at the limitations of the system. And sometimes I get someone would criticize the system. I'm not sure exactly what's the opportunity there, but look at the limitations. And next thing is look at the FDA pathway that you're choosing for your system. Is it an IDE or is it going to be a 510K? And in that respect, that will affect your design rationale. Because if you just come up with an idea out of nowhere, and you realize that after talking to Dawn, that the pathway for FDA clearance is an IDE, that changes your business model. And the other thing to do today is to make sure you have an idea that has some IP protection around it. And look to the future, because if you generate one idea, chances are that that's not the final iteration of that, right? If that were the case, we would not have the internet today, and we would not be where we are in technology. There's always an opportunity to improve on it. All right, so I'm going to take you through how we developed the percutaneous pedicle screw system, the Mantis for Stryker spine. And the first thing we did was to see that there was a demand or a need for surgery that can be done in an outpatient setting. And we saw that we have to find ways to operate on elderly patients that are less risky. And so we also wanted to go from the incision on the right to the incision on the left. So the demand to limit how much dissection that you do prompted us to look into solutions that avoid that much dissection. And when Dr. Foley and his colleagues came out with this paper and Medtronic's released the Sexton system, I think what that did was immediately started a interest in percutaneous pedicle screws, and that confirmed to me that the demand for percutaneous pedicle screw was real. Okay, at that point I decided I should jump in, and first thing I mentioned was, now that you established the demand, what are the limitations? Okay, not just criticizing the systems, what are the limitations? And I listed all those limitations here. And from that, I decided what are the design rationale for this new system that we want to develop. And so we start going through the competition and look at the design considerations for this new system, right? And these are listed, these here. And we went through, and those are actually the actual list that I came up with. And then at the end of it, this is where we ended up with a system that we wanted to be simple in its design. And the next question on the list was, can we patent this and protect it? Because if we can't, then the value may be questionable, right? So I filed that patent with the initial design being what it is here. But the next step was, if I'm going to sell this, I need to come up with a name that can be marketed. And so I came up with this acronym for the Mantis. We trademarked that. The next step was, let's decide, what do we want to do with this system now? Do you want to make a whole company out of it? Do you want to pitch it to a company and sell it? Do you want to license it? And also look at what's the regulatory pathway. And in this case, we wanted to do a 510K. We consider CE mark. And so at that point, we felt, we'd like to sell it to a company. If we wanted to take it on our own, then we would have to incorporate a company, get surgeons to test it out and prove the concept. And that's actually a good idea, because you can build value in the product at that point. So these are all considerations as you develop your product. And now, in our case, we decided to partner with an outside OEM company and develop the prototype and prove the concept out. And this is what we did. We went to SolidWorks, which is standard in the product design phase, and tried to simplify the design and illustrate how it would work, come up with some instrumentation, and finally that was the final prototype design, and that was actually testing in a cadaver. And so we felt, as we got to the point where we wanted to finalize our design and we're doing the cadaver testing, we realized we wanted the ability to contour the rod outside of the body before we put it in. So, you develop the product, the team comes together, you get it to the surgeon, and you get additional feedback. You keep going back and forth between the clinical setting and your product development team and engineers. That's really an important step. And then once we felt that we're ready to go in the surgeon's hands, we get a chance to test it out finally. Then, because our idea was to sell it to a company, we package it nicely. And at this point, being the person who came up with the idea doesn't mean you're going to be the person that's going to sell it. And so at this point, we had someone else go out and pitch it to the companies. And my role was just to test it, and then we sold it to Stryker. At that point, as the inventor, you can make a choice as to how much do you want to participate and champion this product from here on. And in my case, I decided I did not want to champion the product. I want to move on and start a whole new company. And but as an inventor, you have the ability to participate in championing and marketing the product. And this was an idea that we came up with. We wanted to really push this product. This was right around Transformer 1, right? You get the idea. This is old stuff now. But back then I was very excited. I was into it. But then once I jumped ship, I don't know what happened to the product after that, actually. Now, the next thing is you get it in the surgeon's hands. You're still in the product development, because you're refining it. You're trying to see what are the changes you need to make. What's going to be the next generation of your product, and so you start going with the surgeons and looking at the clinical scenarios in which the surgeon can apply it. And so we started to accumulate cases, see how patients do. Those are your clinical trials. It's still part of your product development effort, and you can see the difference in these incisions here compared to where we started out, to define the demand. At this point, you should really feel good about yourself developing a product that definitely improves the clinical scenario. And then we started to expand that and look at what's the next iteration of your product. How do you make it better? And here you can see we're marrying this to facet screws. That's now 2011. We sold this to Stryker in 2005. So 6 years later, the patents finally got published. So you develop your product and you file your patent, but it takes 4 to 6 years before you actually get the issued patent. You could have waited until it was issued, see if it generated more value, but you also taking a risk. You have to balance that. When do you exit from this product? versus, your value balance. And at this point, for me, as I look at the competition and where the Mantis fits, I thought another option which was even less invasive was facets fixation. And so I started Spine Frontier with the facet fuse because I felt it was better than percutaneous pedicle screws. So the idea is to continuously be pushing the limit. So we started out on the left with a demand for a better system than open surgery. We got to percutaneous pedicle screws, and then we got to one incision with facet screws. So, if you sit on your product too long, you can miss the boat. So always, trying to generate new ideas. And so I started to, again, the process of looking at the next generation of percutaneous pedicle screws, and at the same time that we started a new company looking at facet screws. And this is the newest percutaneous pedicle screw system, and it's a paradigm shift from the Mantis and the other systems out there. And we released this back in 2011 at NAS, and this system is quietly being beta tested right now, actually in surgery. So I like to show you how much I'm in love with the Mantis. So I haven't developed a system. We're now in a marketing stage of it, and so you try to illustrate exactly what you want your system to do, and I think animation is a great way to do that. So I'll just show you this new paradigm in percutaneous pedicle screw fixation. Okay, at this point is where we divert from any pedicle screw system, percutaneous system that's out there. Instead of pushing the rod, you now pull the rod through. So this is the whole paradigm shift that you won't see anywhere on the floors here. But this currently isn't being used outside of this convention. So essentially you can go from T2 to the sacrum now very safely without any fluoroscopy, because basically you pull the rod through instead of pushing it. We also attached a pusher to it, so as you're pulling it, you're pushing at the same time. You have ultimate control of where the rod ends up, so you can choose the appropriate length of your rod, and you can always control that rod at any point during the operation. You can't do that with any system right now. Once you're in, you're in. We can take this out. And so if the other thing we do is we put a longer tulip on the screws, so once you go percutaneously, it's easier to get your set screws down. So that's a new paradigm. Any questions? Questions about the music?